Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. So the last part of the chapter will consider the stability of immersed and floating bodies. So first of all, let's consider immersed body. So generally, for a fully immersed body to be stable, we need to have center of buoyancy above center of gravity. If the center of buoyancy is below the center of gravity, then the body will be unstable. So any disturbance will cause it to flip so that the center of buoyancy will be above the center of gravity. But in general, if we have a uniform density body, the center of buoyancy and the center of gravity will be at the same place. So if we consider a body which is fully immersed in a liquid, and let's say the center of buoyancy is above center of gravity. So here is center of buoyancy, whereby the buoyancy force is acting directly upward, and then the center of gravity is below, so the weight is acting downward. And let's say we disturb the body to the left. So what happened? We actually create a anti-clockwise movement. When we disturb the body, what will happen is that there will be a movement created in these directions, which is trying to correct the positions of the body to its original positions. And because of this, the body will be stable. So this one will be stable. Now, let us consider the case whereby the center of gravity is above the center of buoyancy, as shown in this diagram here. So, this is center of buoyancy, so buoyancy force is acting upward, and this is center of gravity, so gravitational force is acting directly downward. And let's say again we disturb the body to the left and see what happens. So, we actually apply a moment this way, and the disturbance will cause the body to be tilted to the left. And what will happen is that there will be an overturning movement generated due to the weight and the buoyancy force. And because of that, the body will be turned around. So this is unstable. So we can conclude that for an immersed body to be stable, the center of buoyancy has to be above the center of gravity. And then take note also that if the density of the body is uniform, center of buoyancy will be at the same place as center of gravity. For the fully immersed body that we considered just now, if the center of buoyancy is above center of gravity, then the body will be stable. But for floating body, the analysis will be more complicated. We need to do more detailed analysis to determine the stability of floating bodies. And the fact that center of buoyancy is above center of gravity may not lead to stable conditions, and vice versa. If the center of gravity is above of center of buoyancy, the floating body may be stable as well. Let's consider these two examples. So the first example is as shown in this diagram here. So here we have center of gravity above center of buoyancy. So we have a body which is floating in water. The weight will be acting at the centroid of the body, so in the middle, downward. And then the buoyancy force will be acting slightly below because the volume which is immersed are lesser than the total volume of the body. So the buoyancy force will be acting at the center of buoyancy upward. If we disturb this body such that applying an anti-clockwise movement, what will happen is that the volume of the body which is submerged underwater will change. Because of this, the center of buoyancy now has moved to the left. So we apply anti-clockwise movement, and what will happen is that the arrangements of the weight and the buoyancy force will create a correcting moment. So this case will be stable. So now, if we look at another case whereby again the center of gravity is above the center of buoyancy, as shown in this diagram here. So again, the weight will be acting from the COG at the center, acting downward, and then buoyancy force will be acting through the center of buoyancy, which is slightly below, because the volume which is immersed underwater is lesser than the total volume of the body. So now, if we apply an anti-clockwise movement to the body, so what will happen is that the shapes of the volume which is submerged underwater has changed and caused the center of buoyancy to move to the right. And because of that, the arrangement of the weight and the buoyancy force will create an overturning moment. So this will be unstable. So for both cases, the center of gravity is above center of buoyancy, but in this case it's stable, and in this case it's unstable. So in order to determine the stability of a floating body, it requires us to do further analysis, which is not covered in this course. So now we come to the end of chapter 3. So if you recall, in chapter 3, we have covered quite a lot of topics. First of all, we have looked at fluid pressure at a point, and then after that, we derive an equations which allow us to calculate the pressure variations with elevations. We have concluded that the piezometric pressure in any static fluid is constant. And then after that, using that principle, we have analyzed different pressure measuring devices, starting from barometer, piezometer, manometer, and then a differential manometer. Then after that, we looked at hydrostatic paradox, followed by hydrostatic force on flat surface, and then continued with hydrostatic force on curved surface. Then after that, we looked at buoyancy, and finally, just now, we have looked at the stability of immersed and floating bodies. So in the next chapter, we will start looking at fluid, which is flowing.